All right, let's talk about energy, but probably not in the way you're used to thinking about it. We're going to look at it from a few totally different angles, starting with the power inside a single person, all the way up to the power of our entire civilization. And we'll frame it all against the vastness of deep time. Let's jump in.
I want to start with this image. Picture a highway at night, from way up high. You could describe it as remarkable illuminated ribbons of rock covered by migrating mammals in metal. It's a pretty wild way to talk about traffic, isn't it? Just hold on to that image, because we're going to come back to it, and by the end of this, it's going to mean something completely different.
Okay, so first things first. To really get a grip on a huge concept like energy, we've got to shrink it down, way down. We're going to start at a scale we can all intuitively understand, ourselves.
This is the number, 100 watts. That's it. That's the baseline power it takes to keep you running.
So what does that even mean, 100 watts? Well, think about everything your body is doing right this second. Thinking, breathing, pumping blood, just staying warm. All of that work adds up to about 2,300 food calories every day. And if you translate that into the language of power, it's pretty much the same as leaving a 100-watt light bulb switched on 24/7. That's you. That's our starting point.
So that's our biological power, our own personal engine. But what happens when we use technology to push beyond that? Well, this is where the scale of energy just completely explodes. I know it's a simple statement, but from a pure energy perspective, it is profoundly true. We kind of take it for granted, but the amount of concentrated power packed into something like gasoline is almost impossible to comprehend. And what about this number? 300,000. What do you think that is? It's the amount of work, and get this, we're going to measure it in push-ups. That is energetically the same as what's in a single gallon of gasoline. 300,000 push-ups. Just to wrap your head around that, imagine trying to do that much work yourself. You would have to do 100 push-ups every single day for 10 years straight. All of that sweat, all that physical effort is the energy that's locked away inside just 1 gallon of gas. So let's put this into motion. Remember our 100-watt human? Well, driving your car down the highway at a nice, steady speed takes about 20,000 watts of power, and most of that is just for pushing air out of the way. The difference is, it's just staggering. When you get in your car, you are amplifying your personal power by 200 times. It's like you suddenly have 200 invisible energy servants doing all the heavy lifting for you, all thanks to that gasoline. But it kind of begs the question, right? Where does all of that incredible energy even come from? To answer that, we have to completely shift gears. We need to step away from technology for a minute and look at how nature came up with its own really elegant solution for capturing energy from the ultimate source, the sun. It's a funny question, I know, but let's actually take it seriously. What if we had to generate our own 100 watts of power directly from sunlight, just like a plant does? The math is actually pretty simple. The sun is constantly bathing the Earth's surface in about 250 watts of energy per square meter. Photosynthesis, for all its biological magic, is only about 2.5% efficient at converting that sunlight into usable energy. So, if you do the math, to generate your own personal 100 watts, you'd need to carry around your own personal solar collector, a leaf, that's more than 15 feet wide. A little impractical, yeah? So why don't we see animals walking around with giant leaves attached to them? Because of this. This is the most fundamental agreement in the history of complex life. It's a bargain, a deal struck between the plants and the animals. Plants essentially said, hey, we'll do the hard work, we'll stay put, we'll hold up these giant solar collectors, and we'll store all that energy. And in exchange, animals like us come along, we eat their fruit, we get that concentrated energy, and in the process, we spread their seeds around so they can reproduce. This deal, this is what allowed animals to be mobile, to develop brains, to become, well, us. Okay, now for the final piece of this puzzle. Let's connect our incredible technological power, that 200x amplification, all the way back to nature's ancient bargain. But this time, let's zoom the camera way, way out, to the scale of deep geological time. Remember our opening image, the highway at night? The absolutely crucial point here is that the fuel burning in those cars, that amazing gasoline, is just ancient buried sunlight. It's the stored energy from countless plants that took part in that bargain over hundreds of millions of years, died, and got compressed into what we now call fossil fuels. And this
This is what puts our entire moment in history into shocking perspective. It took nature 500 million years to slowly, patiently accumulate this vast battery of solar energy, and we are on track to burn through most of it in just a couple of centuries. The source material puts it this way. It's an expenditure happening in a tenth of 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 the tenth of the time it took to collect.
Which brings us right back to that ancient agreement. It was based on a sustainable, balanced exchange of energy. By burning through 500 million years of stored sunlight in what is literally the blink of a geological eye, we have to ask ourselves a pretty critical question. Are we still keeping our side of the bargain?